Hello friends, welcome back to my YouTube channel. In this video, we are going to discuss the resource awareness optimization design patterns, a powerful approach that helps the multiple agents efficiently communicate, collaborate, and coordinate while making the optimal use of available resources. So, without wasting any time, let's get started. So, resource aware optimizations. So, what is it? So, resource aware optimization is an agentic design pattern where an intelligent agent explicitly reason about the system constraints such as a CPU, memory, GPU, tokens, latencies, cost, and energy, and that adapts its decision dynamically while planning, reasoning, and acting. So, in short, the agent optimizes how it works, not just for the regions. So, this is the content and why this pattern exists. So in real systems the resources are finite and expensive. If we go without the resource awareness, LLM cost grow uncontrolled and latency SLA are violated and system crashes under like OOM, out of memory error, rate limits. Agent behaves well in demos but fail in productions. So this pattern makes more agent production safe and scalable. So what is the core idea behind it? So agents should reason not only about what to do but also how much it will be cost to do. So this idea changes an agent from a task solution into a decision maker under constraints. So which is exactly how real production systems must have behaves. So the agent continuously observe uh, available resources, right? So and predict resource consumptions and choose an action plan that maximize the output under constraints, right? So these are the core idea behind it while um, um, choosing the right resources a consider means if we talk about some kind of cost things. So okay, so agent cost is just money, it includes the computing then compute like the CPU GPU uses is talk about memory, the RAM context window is talking about, right? Tokens, so it directly related to the LLM's API cost. Latency, it's directly related to the response time and SLA. And what's for the energy, the battery power edge devices. So every action is has a resource footprint. So that is the core idea. Okay, and next is resource dimensions considered. So in resource awareness optimization, an agent treat systems as a first class input into a decision making. So each dimension represents a constraints that directly influence the planning, um, reasoning depth, tool uses, and execution strategies. So the first is the resource type, and I just is the example. So first is the compute. So that is talk about the CPU percentage, GPU, VRAM. So what it means? So CPU percentage is control parallelisms and throughput. GPU VRAM its limits model size and batch processings. So high compute usage is equal to slower response or failures. And GPU shortage, it cannot be large models. So the agent behavior switch to the smaller model, and it reduces the parallel task and queues or deletes non-critical works is here. Next is the memos, that is RAM, a cache size. So RAM is used in the context windowing, embedding, intermediate states, and cache reuse the past results. So if the memory overflow and the memory crashes, so here the memory RAM and cache size come into the pictures. So here the agent behavior, it looks like chunk large inputs and summarize the intermediate results and reuse the cache intelligently. Third is the cost. API sends total budgets. So total token usage mapped directly to the money, and budgets limits per request or per day. Next is the time, latency and deadlines. So its latency is based on user experience and deadline is the system SLA. So if the agent is slow, it's having the bad user experience, and SLA violation means they're having the missed deadlines. Next is energy, battery usage, power usage. So the power availability on mobile edge devices. So if it is high energy usage, then device gets shut down. Next is the network bandwidth and rate limits. So API call limits, we can and available bandwidth, and why it is matter. If it is if it is a throttling happening, it should fail. And network delay, that's like network spikes. So the each resource dimension act as a boundary conditions that shapes how an agent thinks and acts. So the agent does not aim for maximize the intelligence but for optimal intelligence within the constraints. So the resource aware agents treat compute, memory, cost, time, energy, and networks as input to the reasoning, not the afterthought. Okay, so this is about the resource dimension considers. Next is optimization strategies. So in resource aware optimizations, an agents does not blindly use the best and or most powerful options. Instead of it, it adapts its strategy based on the available resources and constraints and required qualities. So the model selections. So right model, right time. So uh, the agent dynamically choose which LLMs to be used instead of always calling a large language models, because that is the expensive model. So if we talk about the small LLMs, it's a simple, factual or repetitive task. If we talk about the large LLM, it's having the complex reasoning, ambiguity and creativity. So the large model which having the higher cost, latency and GPU uses. A small model often give good enough results. So tool gettings. Call tools only when it is needed. So the agent decide whether a API tool call is worth the cost. So high confidence answer, no tool call is required. Low confidence or high risk, use tool, and cached or local data prefer first. So tool call increase latency, costs and failure risk. Next is adaptive reasoning depth. So the agent control how deeply is reasoned based on the time and resources. So if how it works, so if we have the tight latency, then it shows the solo reasonings, and if we relax constraint, then it shows the deeper plannings. So the deep reasonings consume more tokens and time, so no every task needs multi-step reasonings here. Next is the graceful decreations. So when the resources are tight, the agent degrade quality and instead of failing completely. So it should be have a shorter answer, summarize instead of full analysis, and approximate result instead of extract ones. So but why this matters? So user prefer the sometimes or over nothing. Keep SLA intact. So the control degradation preserves trust and availability. So these are the optimization strategies. Next, we talk about some real world use case here. So it is using in enterprise AI platforms, and where the controlling LLM API cost that meets the SLA, edge mobile agents, battery awareness reasonings, offline first executions, and autonomous systems. And in the autonomous systems, where we can use robotics and IoTs and real-time constraints handling. And what are the benefits here? Benefits of using the resource awareness optimizations. So resource awareness aware optimization turn agent into a production ready system instead of experimental demos. So each benefit shows directly address real problems faced when deploying agentic AI at the scale. So first is the predictable costs. So the agent actively control how much it's spent on LLM tokens, API call, compute, CPU and GPU. Next is higher system stability. So the system avoid crashes, overloads and cascading failures. But why this matter required? So production agent face GPU out of memory error, some kind of memory leaks and rate limit failures. So this uh, this higher system stability that helps agents to monitor resource uses continuously, and it reduces the workload when resources are tight, and finally it degrades the gracefully instead of failing. Better SLA compliance. So the agent consistently meets latency and availability guarantees. So if we have the missing SLA leads, that leads to poor user experience, contract penalties and loss of trust. So this will help to choose the faster model under the time pressure, and it skips how and slow tools when deadlines are tight, and return the partial result if needed. A scale to the production. So the system works not just for the 10 users, that is for the millions users. So agent behaviors that is acceptable at a large scale become dangerous at a large scale. So how the agent helps here? So so the agent enforces per request and global budget, and it shares the resource fairly across agents, and it adapts the behavior based on the system load. A smarter autonomous behavior. So agent behaves like experienced engineer, and not the native task solver. So it helps to weigh quality versus cost versus time, right? So in the big picture inside, if we talk about, so it ensured that the agents are cost conscious and stable, SLA, and scalable and truly autonomous. So these benefits makes resource aware optimization a must have pattern for any production grade agentic AI systems. What will happen if we go with without resource awareness optimizations? So when the agents are not resource aware, so they behaves like a native problem solvers. They focus only on completing the task and ignoring the real world constraints, right? At the smaller scale this looks fine, but at production grade it's having the problems. But without if you go without this pattern, the first point is cost explosion. So agent always used large LLMs, and it's unlimited reasoning steps and frequent tool and API calls. So which break the each tokens computes money. So result is unexpected and uncontrollable AI spending. Next is latency violations. So agent reason deeply even when not needed, and it's called external tools every times. So as a result, it slows the system and frustrated users. Uh, Once a slow system, the user got frustrated. GPU OOM errors. So large language model load blindly over and oversize the context windowing and no aware of VRM limits, which breaks the GPU memory is which breaks it will break, right? And then our GPU memory is finite, and once it exceeded and hard to crash, and as a result, the service downtime and cascading failures. Poor user experience, then means timeout, inconsistent sensor, failure message. So this is poor user experience, and a scalable agent. So it will work for 10 users, but it breaks on the like millions of users, on the millions of users. So as a result, the systems that must be redesigned from the scratch. Okay. So the agent that ignored the resources is intelligent in the theory, but recklessness is the reality. So this is the architectural flow of resource aware architectures. So it start from the user, applications users, task request. So input from the user, system or agents. So user is asking some kind of query. So there is a task interpreter is here. Task interpreter understand the what kind of task is, that is simple QA or deep reasoning or too heavy task. And then resource monitoring, that is the critical window. That is the critical window. And resource monitoring is continuously track the GPU, CPU, memory uses, token and cost budget, and SLS. And next it goes to the cost awareness planner, and where we generate the multiple execution plans, and each plan executes the model choice, tool required, reasoning depth, and cost, estimated costs and latencies. Next is the optimizer. It we need to optimize it. So select the best plan under the constraints, optimize for the cost, time, quality, and stability. Right. And next is the execution engines that executes the chosen plan and is called the selected LLMs. And then feedback and learning loop is there with adjust the cost and actual latencies, and it's improve over the times. And finally it generates the output. So this is all about the architectures. So that's all for today. If this video helped you to understand the resource aware optimization design pattern, don't forget to like, subscribe and share. See you in next one. Thank you.